side should say Notes 4.4 Factoring Polynomial, and it's got all the bubbles and the squares, and it looks something like this, Factoring Polynomials. Okay, so I think I'll be able to zoom in. I thought I could do more. Oh, there, yeah. Okay, now look in the center of the sheet. We are in the business as we progress in math and move higher up. We want to start thinking ahead so that we are doing something called working smarter, not harder, right? And we've got to stress this to ourselves because the things that are frustrating about math we can sometimes avoid. So in the very center of the notes, it tells you what should you always do first. Okay, and I like that. We translated GCF as greatest common factor. How would you describe to someone in Algebra 1 what greatest common factor is? Talk to your groups right now and tell them, what is the greatest common factor? Algebra 1? It's like, get ready for your quiz. Okay, so hopefully you and your group members talked about something like, it's the biggest number that goes into all the terms. It's the thing I can divide out of all the terms. Now, the greatest common factor, it has to be the one like that they all share the largest value. Okay, so that when you factor it out, there's nothing left over. Okay, so first look for a GCF. Then I'm going to go over to the right, because this is a very common situation. We have this trinomials bubble. Trinomial means how many terms? 3. So use this when you have 3 terms. Go ahead and calibrate my board real fast. Okay, now notice that the trinomials in that bubble are looking different than all the trinomials we saw back in chapter 3. Because in chapter 3 we were working specifically with quadratics, so things of degree 2. So we saw this first version, ax squared plus bx plus c. But you can also factor other trinomials like polynomials that have higher degrees that are higher than 2. What's the connection you're seeing between like the first and the second term in the other versions? Yeah, so that's kind of like a good signal to you, like, can I factor this trinomial like I used to factor trinomials in chapter 3? It's like, is that middle term's exponent half of the first term's exponent? Then yes. So give me another example besides ax to the 6th. Ax to the 8th plus bx to the 4th plus c could also be factored, right? Okay, so kind of think about that pattern. That's going to tell you whether or not something can be factored. And let's look down at the examples there. So we're looking at 5x to the 6th minus 25x to the 4th plus 30x squared. What do you notice about all terms there? They all have a factor of 5. What else do they all have? An x squared. Okay, so first I got to look for my greatest common factor. I'm going to take a 5x squared out of every single term. Now, can you still factor without doing that first? Yes, but it's not always as easy if you take the GCF out first. So we're in the business of working smarter, not harder. We're going to factor the GCF out right away. Okay. Then, write what's left over. Okay, so if I take 5x to the 6th and I divide by 5x squared, what's left over? X to the 4th. I'm subtracting my exponents. X to the 6th divided by x squared. 6 minus 2 is 4. Okay, and then 5 over 5 is 1. Negative 25x to the 4th divided by 5x squared. Minus 5x squared. And then 30x squared divided by 5x squared is just plus 6. So now instead of factoring a trinomial with x to the 6th, x to the 4th, x squared, I'm just factoring a polynomial x to the fourth, x squared, and a constant term, and those are probably easier for you. So then my next step, I got to keep this 5x squared. Oops. I'm going to have two groups of parentheses. To figure out the first term in both groups of parentheses, what sort of things would I be multiplying together to get that x to the fourth? X squared times x squared. So my first terms are going to be x squared in both. Why wouldn't I choose x to the third and x? How do I know that's definitely not the things that multiply to make x to the fourth? To be honest, x to the third times x is x to the fourth. Why did I choose x squared and not? What's that? No, Kaylee? Yeah, I would say it's like looking at my middle term, right? Look at my middle term. My middle term is x squared. There are no x cubed or x to the first terms in the rest of the polynomial, right? So I can pretty much guess it's going to be x squared and x squared. Then, as long as my leading coefficient there is 1, I can use my shortcut. What are factors of 6 that add to make negative 5? Okay, so 6 is a tricky one. I'm glad you said that, Aiden. There's 2 and 3, and there's 6 and 1. Which pair are we going to use? Because you said it. Talk to your group. Which one is the right one to use? 2 and 3, 6 and 1, or does it even matter? Tell your group. Oh, okay. Okay, what's the correct pair to use?
2 and 3.
2 and 3, and the reasoning would be because you have a plus 6 at the back, you either have to be using both positive factors or both negative factors. Because it's a positive 6 and that they have to have the same sign because it's a negative 5x squared, they both have to be negatives. And then a negative 6 and a negative 1 would give us negative 7x when we recoil it. So we will use negative 3 and negative 2. Okay. X minus 3 and x minus 2. Okay, now with polynomials, because your degree can be higher than 2, more than a quadratic, it's always a good idea to check the factors that are left over, like x squared minus 3 and x squared minus 2, and make sure that there's no other types of factoring that you can do. Okay. Anybody got any questions about factoring trinomials? That's factored, yeah. That's as good as it would get. Luke.
So you factor out the greatest common factor, and then you factor what's left over.
Yes. Why are you giggling?
It just says
It's funny
factor a lot.
saying you factor out the greatest common factor and then you factor the rest.
Yeah. It's just completely factored with all the factors. Now you guys are going to make me feel nervous about saying the word factor. Okay, I'm actually going to hang out with, or leave this last one. I'll give you some time to see if you can do that on your own here in a little bit. I'm going to go over now to the other side of our note sheet, the difference of perfect squares. Okay, so the difference of perfect squares is one of those things where, again, we're in the business because we're honors algebra 2 and we're going to be going up into higher level math classes. We want to be working smarter, not harder. So if you know the difference of perfect squares, it just makes your life a lot easier. You see it, you instantly know it, and you can factor it right away. It's just a pattern. So you have to have two perfect squares that are being subtracted. That's a squared and b squared. And then in the factors, you're going to put their square roots, a and b. One of the factors is a minus b, the other factor is a plus b. So on that perfect squares line, let's just write down a few perfect squares so that we recall what that list
49, 64, 81,
Which one did you forget or leave off?
121,
One.
140.
Alright, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, so on and so on. That should be a list of numbers you could just rattle off. 1, 4, 9, 16, 25, 36, 49, 64. And you can just run through that list, okay? Alright, so we've got 121 x squared minus 1. Kaylee.
What do we write down for when you have blank terms?
Oh, how many terms would difference of perfect squares have?
2.
2 terms. Okay. Okay, so that's a great reminder to me to talk about. If I came across 121 x squared minus 1, outside of this classroom in another level of math, how would I know to even think about difference of perfect squares? Because it only has 2 terms. So I only have a few options for 2 terms. I would first check for a greatest common factor. Anything you could take out of both of those terms? No, 1, but you don't have to do that. That'd be like way more factoring than they would need to do. And then, now look at them. Are they all perfect squares? Yeah, 121 is perfect square, x squared is perfect square, 1 is perfect square. Are they being subtracted? Is it a difference? Yeah, so remember difference means subtraction. So then, I cofactor it. Remember, in the parentheses, you're just going to put the square roots. So what's the square root of the first term? 11x. Okay, so we're going to have 11x and 11x. What's the square root of the last term? 1. And 1 is going to be plus and 1 is going to be minus. It doesn't matter which order you put the plus or minus. Right? The 2 factors should look exactly the same but have different sign in between. So we would maybe refer to those as like conjugates. Okay. Next up, I'm going to go to factor the sum and difference of perfect cubes. So this one you probably haven't seen before. Does anybody think that maybe you've done it in algebra 1?
No.
Okay. So, now notice when you do perfect squares, it has to be a difference. So subtraction only. When you're doing perfect cubes, it could be a difference or a sum. So you can do it either one. And then look at the way they're set up. A cubed minus B cubed, A cubed plus B cubed. So you would use this when you see how many terms?
3.
2 terms.
2.
There's 2 terms right there.
Oh,
So we'll use that when we have 2 terms. It's just like this, the difference of perfect squares, right? It's 2 perfect squares that are being subtracted. With the sum or difference of perfect cubes, it's either 2 perfect cubes that are added or 2 perfect cubes that are subtracted. Okay, now, again, we're in the business of working smarter, not harder. This thing can sometimes be a challenge for people because to factor sum and difference of perfect cubes, it's basically memorization of a pattern. I will tell you my trick to remember my sum and difference of perfect cubes. Do you notice that the terms are like the same in both lines? A, B, A squared, AB, B squared. It's the signs that change. Okay, so you're going to have to memorize that it's a binomial with A and B, and then a trinomial, A squared, AB, B squared. So you're going to need to be responsible for those terms. To determine my signs, I use a rule I call SOAP. SOAP stands for same, opposite, always positive. And that gives me my 3 signs for the sum or the difference of cubes. So let me show you what that looks like in this rule. If I'm doing a difference of perfect cubes, A cubed minus B cubed, then in the first group of parentheses where I have that binomial with A and B, I have the same sign. So this was a difference. This is also a difference. The next sign in between the a squared and the ab is opposite. So because it was a difference, now it's a plus sign. And then the last term is always positive. That's positive. Okay, so a difference is going to be same, opposite, always positive, negative, positive, positive. A sum is going to be same, opposite, always positive, plus, minus, plus. Okay, and then I just drop in my terms. Okay. For the perfect cubes, or sum and difference of cubes, obviously we need to know perfect cubes. So we could make the list of perfect squares by doing like 1 squared, 2 squared, 3 squared, 4 squared. That's how the same way you can get the list of perfect cubes. So let's write some perfect cubes so we're used to recognizing that. 1 cubed would be 1. 2 cubed,
8.
3 cubed, 4 cubed, 5 cubed, 6 cubed, 216, and let's just for good measure do 7 cubed.
What's 49 times
343. Now you could go in and fill in some other ones if you want, and then another one that pops up quite a bit. 1,000 will be 10 cubed. If you want to fill in 8 cubed and 9 cubed in your own notes, you can. Okay, so like you're less familiar with that list. So again, think about like you as an Algebra 2 student. This might be someplace where you have to put in a little extra time and effort because you're unfamiliar with the perfect cubes or the list of perfect cubes. So make sure you kind of always looking for those. If it's not a difference of perfect squares, then I check for perfect cubes. Okay, so let's look at this first one. X cubed plus 64. Is x cubed a perfect cube? Yes. Is 64 a perfect cube?
Yes.
Yeah, so we're going to use, obviously, sum or difference of cubes. We're going to follow the sum rule. Okay, so this is the rule for sum. And one thing I do in the beginning when I'm like you guys, I'm just learning sum and difference of cubes, I write down what A and B are. A and B are the cube roots. Okay, what's the cube root of x cubed? X. What's the cube root of 64? 4. And let me just say this real quick about A and B. You never ever have to worry about their signs. So always write A and B as like positive numbers. The SOAP rule, same, opposite, always positive, takes care of all your sign issues. So never ever do you have to worry about B being negative. They always label it positive. Never ever do you have to worry about that. Okay, so now here's where I like put my nose to the grindstone and make sure I know how to do the sum and difference of cubes. It's basically a pattern, a memorization piece here. So the first one's a binomial with A and B, so x and 4. It's going to be plus because it's going to have the same sign. And then in this trinomial, my bookend pieces are the squares, right? So I'm going to have x squared and 16. The middle term is just the product of A and B multiplied. So x times 4 is 4x. And then follow my rule, same, opposite, always positive. There, I just factored. Okay. Now, I'm going to say it's going to be worthwhile for us to talk about the next one. If I came across negative 16x to the 5th plus 250x squared, now I notice that it has only 2 terms. 16 is a perfect square, but x to the 5th isn't. 16 is not a perfect cube. So then what else might I be doing? The first thing I should check for. That greatest common factor. So I I noticed these are some bigger numbers. What can you take out of both of those things? You can take out an x squared, and someone also said 16 I don't think goes into 250. Ooh, 4 doesn't go into 250. Remember the rule of 50 is not divisible by 4, then 250 is not divisible by 4. The last two digits. 2. Someone said 2. And on this one, I would probably, because my leading term is negative, I would probably take out a negative 2. So I'm going to take out a negative 2x squared. I usually like always when factoring for my first term to be positive. Okay, so negative 16x to the 5th divided by negative 2x squared. 8x cubed. 250x squared divided by negative 2x squared. Minus 125. No x, right? The x squared over x squared cancels. Okay. When I take out a GCF, then I notice it's a difference of perfect cubes. 8 is perfect cubed. X cubed is a perfect cube. Negative 125 is perfect cube. Or 125 is perfect cube. So what's your A value? 2x. What's your B value? 5. And remember, you never ever have to worry about a negative there. The SOAP, same opposite, always positive, does all your work for you. Okay, that's the nice thing about the pattern. Okay, so I'm going to have my negative 2x squared hanging out. I know I'm going to start with a binomial. The binomial is either a plus b or a minus b. Since this is a difference of perfect cubes, like Luke told us, we'll put in 2x minus 5, keep the same sign as what's in the original polynomial. So it's going to be 2x minus 5. Here's where you got to be really careful, you guys. This happens in Pascal's too. If a is 2x, and you square a, what do you get? 4x squared. I'm going to get a lot of 2x squareds. Can you imagine that? Some of your classmates forgetting to square the 2? Can you imagine? Don't let it be you. Okay. So I'm going to write down here below this, this is going to be 2x quantity squared, which that's then 4x squared. Okay, so that I know when I look back at my notes where I got that number. The last term is going to be b squared, which will just be 25. And the middle term is just the product of those two. So 10x. And then follow my same opposite, always positive. So same sign was negative, opposite sign will be positive, and this one is always positive with plus. Luke.
Will we eventually, would it ever be possible to factor that trinomial that's left over?
That is an excellent question, Luke. The answer is no. Okay? All of these, like x cubed minus b cubed things, these are all cubic functions with only an x cubed. And the parent graph for y equals x cubed looks like this. Okay? That's a cubic function. And if you just put like a perfect cube, whether you're adding or subtracting 8, that's essentially a vertical shift. So when you think about a, h, and k, I'm never going to put in like an x squared or an x because then it's not a difference of perfect cubes, right? So when you only have an x cubed, it's just shifting this graph up and down. Okay? So I could have a cubic function up here. I could have a cubic function down here. Okay, so I'm just sliding that cubic function. At most, that cubic function, because it never ever turns around, it only like bends, but it's still increasing. At most, it will cross the x-axis one time. All those pictures that I drew up there cross one time. So that means the other two zeros are imaginary. They don't show up on the graph as x-intercepts. That graph never turns around. So then they must be imaginary solutions. Okay. Good question. Okay. Last one we got to talk about. We've got, when you have two terms, you can try for difference of perfect squares, sum or difference of perfect cubes, or simply just factoring out the greatest common factor. When you have three terms, treat it like an old trinomial. Okay. When do you use grouping? How many terms would you have? When you have four terms, Hagen says. You have four terms. So when it looks too complicated because you have four terms, you're going to use factor by grouping. Now, I'm going to model like that circle, what that's saying. I'm going to do it by doing this example for us. So I've got x cubed minus 2x squared minus 9x plus 18. They don't share any greatest common factor, all four terms. Of course, I should check for that. And then there's like too much to factor. There's too many terms. So factor by grouping says group them in even terms. So with 4, I can group them 2 and 2. Okay. So I'm going to focus first on the first two. X cubed minus 2x squared. They share a greatest common factor. What's the greatest common factor for those two terms? X squared. And then I'm left with x minus 2. Then I'm going to look at the last two terms, negative 9x plus 18, and they share a greatest common factor. What do negative 9x and 18 share? 9, but always, if there's a negative in the front, take out a negative. So I'm going to take out a negative 9. Okay. Negative 9x divided by negative 9 is x. 18 divided by negative 9 is negative 2. Because I've taken out the negative 9, so it's going to change its sign. And always you have to take something out. If those two terms didn't share anything in common, I would have to take out either a plus 1 or a negative 1. It would just depend on what the sign of the third term is, if it should be plus or minus. Okay. Now, in order for you to do factor by grouping, these two factors, a plus b, they have to be exactly the same. If one of those was x minus 2 and the other was x plus 2, not factorable. Move on. Okay. So they have to be the same. And then essentially what you're doing is you're undistributing this a plus b. So imagine a plus b had been distributed to r and also to s. We could write that as a plus b times the quantity r plus s, undistribute. Okay. So one of our factors is going to be x minus 2, the one that we undistribute. The other factor are these coefficients. So we're going to have x squared minus 9. No, you could do x squared minus 9 and then x minus 2. But there's the reason why you always have to take something out, even a plus 1 or a minus 1. It will be a binomial over here. Okay. Now, what do you notice about those two factors? Yes? What do you notice about one of those factors? It's the difference of perfect squares. So have I finished factoring? So this is going to be x minus 2 times x minus 3, x plus 3. Doesn't matter what order you put those. So with polynomials, you've always got to do that extra check at the end. It might be possible for you to factor, but with Luke's question, thanks for asking that, Luke, you never ever have to check to see if you could factor that trinomial and sum or difference of perfect cubes. Not going to happen because it's imaginary solutions. But when you do factor by grouping, if you're doing a trinomial, you might want to check for difference of perfect squares, okay? Okay, you have a homework assignment on your goal sheet. It's factoring. Remember, there is no hiding from this factoring skill. If you don't get it tonight, hopefully you'll get it tomorrow night. If you don't get it tomorrow night, hopefully our activity on Wednesday will help. Okay? You got to keep pushing through.